restart it. So thank you, Eva, for your talk, and we'll move on to our next speaker. Our next speaker is Suzie Cro. Dr. Suzie Cro, who's going to talk to us about using or not using individual patient data. And Dr. Cro is coming to us from Imperial College London today. She's a superb statistician there and will help us think about these issues. Thank you, Dr. Cro, for joining us today.
Hi, Robert, and hi, everyone else. Thank you for that kind introduction. So, as you said, I'm going to be talking to you about the advantages and disadvantages of using IPD meta-analysis. And this is for a recently conducted systematic review that was in eczema and food allergy prevention studies. So to use or to not use IPD, that's the question that I hope to give you some insight on. And just before I start, I'd like to acknowledge colleagues at Imperial who I've worked with on this analysis, and also the Skincare Interventions for the Prevention of Eczema and Food Allergy International Consortium. Right, so I'm going to begin with a summary of what IPD meta-analysis is and an introduction to the Skincare Interventions for the Prevention of Eczema and Food Allergy Systematic Review, and this included an IPD meta-analysis. So I'll then explore what the value of using IPD analysis was for this review, and I'll do this by presenting a reanalysis using only traditional aggregate data meta-analysis. And then the results of the IPD and aggregate data meta-analysis will then be compared to demonstrate the advantages and disadvantages of using IPD. And I'll finish with a short discussion. Great, so first up, what is IPD meta-analysis? Well, IPD stands for individual participant data, which is the raw data records for individual participants in a study. So it's the original data sourced from trialists. An IPD meta-analysis is where the individual participant data is obtained from similar trials, and then it's pooled to summarize the evidence on a particular clinical question. Now, this differs to traditional meta-analysis, which uses aggregate data, which is obtained typically from publications. And so just by aggregate data, I mean where IPD has already been averaged or an alternative effect measure has been estimated across the patient data. So this might take the form of a risk ratio, odds ratio, mean difference, etc. Now, in aggregate data meta-analysis, the aggregate data from similar trials is extracted and then pooled to summarize the evidence on the particular clinical question. So whilst these are two different ways meta-analysis can be conducted, they both have the same aim and result in a production of a pooled summary measure. Now, IPD meta-analysis is now considered the gold standard approach. And this is because of numerous reasons, including firstly, the ability to apply consistent exclusion and inclusion criteria for participants across studies in the analysis. You can use standardized outcomes and standardized methods across trials, and you have the ability to account for missing data in a consistent way at the participant level and verify results of included studies. IPD can also inform risk of bias assessments, and the results of unpublished studies can be calculated and included. Now, the use of standardized statistical methods across trials means you can estimate treatment effects that are adjusted for baseline characteristics in a consistent manner, and this can increase precision and power within the estimation. And it also allows for meta-analysis of interactions between intervention effects and participant level characteristics, such as patient age. Now, these reasons are why the SkyPad systematic review was designed to include IPD meta-analysis. So SkyPad standing for Skincare Interventions for Preventing Eczema and Food Allergy. Now, this is a Cochrane review that was published just last month, addressing whether skincare interventions in early infancy can prevent eczema and/or food allergy. Now, I was the statistician who performed the IPD analysis for SkyPad. And after doing the analysis, I was really interested in exploring what the value of using IPD was with regards to the results and inference. And so I undertook a replication of the review using aggregate published data only. Now, the methods of the review and the IPD analysis have been published, as I just mentioned before, but in brief, parallel or factorial randomized trials, including infants under 12 months, were included. Now, all skincare interventions that could potentially enhance skin barrier function were of interest and included. So this included moisturizers and emollients, bathing products, advice regarding soap exposure and bathing, or use of water softeners. And then the comparators were no treatment or standard care. Now, the search for this review was run in July 2020. And then for the IPD meta-analysis, all trial authors of eligible studies were then contacted and asked to provide IPD. Data were then transferred and then cleaned for analysis. Now, for the aggregate data analysis and the reanalysis, we used the exact same search results. Now, the aggregate data was then extracted from the publications of the eligible studies, and this was done in duplicate by 2 reviewers. Now, the review's primary outcomes were eczema by age 1 to 3 years, where eczema was measured using the Hannafin and Raj criteria, or the UK Working Party refinement, or other modifications of these. Now, if this wasn't available for a trial, we then took doctor diagnosis, or then took parent report of eczema diagnosis. And the second co-primary outcome, food allergy, was food allergy by age 1 to 3 years, as confirmed by IgE-mediated food allergy using an oral food challenge. Secondary outcomes included the specific adverse events of skin infections, stinging or allergic reactions, slippage accidents, and serious adverse events, and time to onset of eczema, parent report of immediate reaction to a food allergen at 1 to 3 years, and allergic sensitization to foods and inhalants at 1 to 3 years. Now, for data synthesis, in the IPD analysis, we followed a pre-specified SAP and adopted a 2-stage approach to the analysis. Now, what this means is for each separate trial and outcome, we first calculated the effect of interest using the exact same regression model across the trials. This gave us consistent relative risk or hazard ratio estimates. Then in stage 2, inverse variance random effects models were used to obtain the pooled treatment effect. Now, except for safety outcomes that were unadjusted, all stage 1 models included adjustment for sex and family history of atopy. This was within the models. And so consequently, we get adjusted risk ratios in the IPD analysis. So this was done to increase precision within estimation. Some of the trials included only those at higher risk for allergic disease based on parental atopy, while others had a variety of risks. Now, for the aggregate data meta-analysis, inverse variance random effects models were used to pull the extracted risk ratios or hazard ratios that come from publications. Now, most of the trials reported unadjusted effects, and so we combined extracted unadjusted relative risk or hazard ratio estimates. And we did also do sensitivity analysis, including any published adjusted effect sizes, but there weren't many of those. This is the key point that I want to make note of, is that as the aggregate meta-analysis used unadjusted treatment estimates, please remember we don't expect all the aggregate data and the IPD meta-analysis results to be exactly the same, as IPD enabled a consistent adjustment of risk for atopy and sex to increase precision. Now, just lastly on methods, the Cochrane risk of bias 2 tool was used to assess risk of bias for both analyses. And the certainty of the evidence was assessed using the grade approach. And across all meta-analyses, the I-squared statistic and chi-squared tests have been used to quantify the degree of statistical heterogeneity. Great, so that's the methods here. So I'm now going to start summarising the differences between the aggregate data and IPD meta-analysis results. And this will start with the total number of studies included in the analyses. So the search that was run yielded 11 trials eligible to be included in one or more meta-analysis, as they included at least one relevant outcome. Now, of these, individual patient data was obtained from 10 studies with a total of 5,154 participants. Now, there was one study with 60 participants that didn't provide any IPD. Now, for the aggregate data analysis, one trial that supplied IPD has not actually yet been analysed or reported, so it couldn't be included in the aggregate data analysis. But we could include the trial that previously did not provide IPD. So there were also 10 trials included in the aggregate data meta-analysis with this difference. So I've now got the results for the co-primary outcomes. And first up is eczema. So the pooled primary result for eczema was similar between the analyses, indicating no benefit of early skin care interventions on eczema. Now in the IPD analysis, which is shown in the top figure, the pooled adjusted relative risk was 1.03, with a 95% confidence interval going from 0.81 to 1.31. So this was based on 7 studies, and we got an I-squared of 41%, indicating moderate heterogeneity. Now in the aggregate data meta-analysis, which is in the bottom figure, the unadjusted relative risk was 1.01, with a confidence interval from 0.77 to 1.33. Now this was also based on 7 studies, but with the difference described on the previous slide. And in this analysis, we had an I-squared of 53%. Now, although these results might initially appear not too dissimilar, there are some key differences to point out. So we see there was an increase in precision and a reduction of the statistical heterogeneity in the IPD meta-analysis. This went from 53% in the aggregate data analysis to 41%. But moreover, the heterogeneity of 41% in the IPD analysis could be entirely explained by one trial in the IPD analysis. So this was the Skjerven trial that had a relative risk favouring standard of care. So if I just, this guy here. Now, when this one trial was excluded in the IPD meta-analysis, which is shown in the top figure here, see the I-squared is now reduced to 0 with the remaining 6 trials, and we get a pooled relative risk of 0.95 with a confidence interval from 0.81 to 1.12. Now, this can be explained by the type of intervention used by the excluded Skjerven trial, which actually was using bathing with oil and moisturiser applied to the face only, initiated from 2 weeks, whilst the other included trials all used more of a body moisturisers or emollients without the bathing aspect. Now, as shown in the bottom figure, in the aggregate data analysis, when we take out the Skjerven trial, this does not alone explain the statistical heterogeneity. Now, after excluding Skjerven, the aggregate data meta-analysis, the pooled treatment effect gives you a relative risk of 0.93 with a confidence interval from 0.72 to 1.28. And we still have an I-squared of 31%. Now, for food allergy, there was only one trial that had this outcome, and the result calculated using IPD was basically the same as the aggregate data with a relative risk of 2.53. This suggesting there may be a harmful effect of skincare intervention on food allergy, but the data is also consistent with either no effect or a potential harm, because we've got, as you can see, we've got wide confidence intervals here. So more trial data is needed to explore this further. Let's now look at the secondary outcomes. So first up, we've got skin infections. Now, in the IPD meta-analysis in the top figure, we had 6 trials included with a total of 2,728 participants. And they provided data on this outcome, and they gave a pooled unadjusted risk ratio of 1.34 with a confidence interval of 1.02 to 1.77. So the lower limit for the confidence interval here isn't including 1. This is giving us a signal of harm here. Now, in the bottom figure, the aggregate data was available for only 3 studies with 1,382 participants. And this gives a pooled unadjusted risk ratio of 1.31 with a confidence interval going from 0.99 to 1.75. So the lower limit of the confidence here for the pooled result is now spanning down to 0.99. So it includes no difference, and it's built upon a lower volume of participant evidence, which you can see quite visibly in the forest plots. Now, on stinging or allergic reactions, as shown in the bottom figure, only 1 study with 100 participants had aggregate data, and this gave a relative risk of 2.13 with a confidence interval of 0.43 to 10.46, so wide confidence interval here. Now, IPD was available from 4 studies with 343 participants, and this gave a pooled relative risk of 2.24 with a confidence interval of 0.67 to 7.43. So this result was similar, but we've got a slight increase of precision using the IPD with a slightly narrower confidence interval, but it's still a wide confidence interval, as you can see in by the size of the diamond here. Now, aggregate data on serious adverse events, as shown in the bottom figure, was reported for just one trial, included 1,171 participants. And this gave an unadjusted relative risk of 0.62, with a confidence interval going from 0.23 to 1.70. Whereas IPD on serious adverse events was available for 3 trials, with a total of 1,367 participants. Now, this was including the one trial that reported aggregate data on serious adverse events. Now, when we had examined the IPD, it actually revealed that not all the serious adverse events had been reported in the trial publication for this one trial here. Now, serious adverse events had only been reported in the publication for participants who had had 2 or more serious adverse events that required the hospitalisation. So in the IPD meta-analysis, the pooled treatment effect for serious adverse events is a bit different here. It's one relative risk of 1.80 with a confidence interval of from 0.45 to 7.18. Now, the other secondary outcome with the difference to note was time to onset of eczema. Now, only 2 trials that had a total of 1,163 participants reported aggregate data on the time to eczema, and they gave a pooled unadjusted treatment effect of a hazard ratio of 0.59 with a confidence interval of 0.44 to 0.80. Using the IPD, we could actually calculate the time to eczema in a consistent manner across 9 trials. So these had 3,349 participants. And so this was using the obtained visit dates and eczema outcomes in the data sets. And this gave a pooled adjusted hazard ratio of 0.86 with a confidence interval of 0.65 to 1.14. Now, other secondary outcome results not reported here, just the time today, were similar between the 2 methods of analysis. Now, the analyses that were only possible using IPD analysis, so these included examinations of whether the treatment effect varied by participant level characteristics. And these characteristics that were looked at were the age of treatment initiation, flagging genotype, and family history of atopic disease. Now, the IPD meta-analysis revealed no significant interactions between these factors and the effect of skincare intervention on eczema. But this insight would not have been possible from just the aggregate data alone. Now, the IPD also enabled us to explore the impact of adherence to the skincare intervention on eczema. So we conducted meta-analysis for the complier average causal effect, and this is also known as CASE. So this had only previously been calculated for one of the trials, and the CASE provides an estimate of the treatment effect for individuals who are able to adhere to the intervention regimen. So the IPD meant we could compute compliance indicators, applying consistent thresholds across trials that supplied compliance data. Then we could calculate the compliance adjusted effect for various different levels of compliance using validated statistical methods to then pool. So the CASE analysis preserves the benefit of randomization. Now, the pooled CASE estimates actually ended up not providing sufficient evidence to determine whether a treatment adherence impacted risk of developing eczema or food allergy, because all the pooled CASE estimates had wide confidence intervals, wider than the primary intention to treat analysis. But these 2 types of analyses were not possible in the aggregate data meta-analysis. Now, on risk of bias, we found the IPD improved some ratings, and this was due to the ability to perform new missing data sensitivity analyses, and also the use of a pre-specified analysis plan for the IPD meta-analysis. So, for example, for the co-primary eczema outcome, there were 3 out of 7 studies that were judged to be of low risk of bias in the IPD meta-analysis. This was compared to only 1 out of 7 in the aggregate data meta-analysis. Now, this and other factors previously discussed, including the reduced heterogeneity, all had an impact on the overall certainty of the review evidence. So the table on the screen now is just summarising the certainty of evidence for each of the main outcomes for the IPD and aggregate data analysis. So the IPD grading here and aggregate data here. Now, I've highlighted in red where the quality of evidence was 1 point lower in the aggregate data analysis, which was the case for 3 out of the 8 main outcomes. So this was due to either more risk of bias without missing data sensitivity analysis, or greater heterogeneity that could not be explained, or decreased precision. So you can see the IPD increased the level of evidence of the review and included the primary eczema outcome at the top there. The level of evidence was low in the aggregate data analysis, but moderate in the IPD. Now, this increased certainty of evidence was not without costs. So the IPD meta-analysis was only achievable because of open, trusting relationships with collaborators, including those who shared their data prior to its original publication, as it was also a prospectively planned IPD meta-analysis. Now, the International Collaboration Group for the project was established in 2017, and the project required meetings for mutual agreements and to build that trust. Now, the Cochrane Protocol was published in 2019, and for each trial partner, data sharing agreements had to be drawn up for data sharing. And this all took effort and time, making it slower and more costly than a retrospective IPD meta-analysis. Now, post-data sharing, more time and effort was naturally required for the analysis. So we had 10 trial data sets to analyse. Each one had to be checked, clean and coded for analysis. An analysis of each trial required the computation of multiple outcomes and sensitivity analysis. Now, one aspect that surprised me that I hadn't initially planned for was the time it took to do missing data sensitivity analyses for each outcome required for the risk of bias 2 assessments. This sort of multiplied the analysis time. So I was quite pleased there wasn't more than 10 trials that came out. But this all naturally involved more costs than a standard aggregate data analysis that required funding. Funding for SkyPad was obtained through a personal NIHR fellowship for Dr. Maeve Kelleher, and also through an NIHR RFPB grant, which included full-time funding for a systematic review coordinator for 2 years, and then 50% funding for the statistician role for 2 years. No, so to summarise, so although it was more timely and costly, the results of the aggregate data meta-analysis here demonstrate the added value of conducting the IPD meta-analysis. So alignment of outcomes and statistical methods across the trials reduced the heterogeneity in pooled results, and consistent adjustment for sex and family history of atopy increased precision. So specifically for the primary eczema outcome, the IPD meta-analysis consequently revealed the Skjerven trial as the main driver of heterogeneity. And this can be explained by the different intervention used in this trial, which is a combination of daily facial emollient with daily baths with paraffin-based bath oil versus the other trials that use daily body emollients. So this observation provides key insights for future research. And overall, the results of the IPD meta-analysis, including for the primary eczema outcome, were judged to be of a higher quality with higher certainty in the findings due to the improved risk of bias 2 assessments and the reduced heterogeneity. Now, the IPD meta-analysis was also demonstrated to be of great value for the analysis of the specific adverse events, which were better powered due to the ability to include more trials. So this giving a more notable signal of harm for the skin infection and stinging or allergic reactions. It meant exploration of the impact of adherence using complier average causal effect analysis was possible, and treatment by patient factor interactions. The main disadvantage was unsurprisingly the increased time, resources and associated costs. So the cost benefit implications of IPD meta-analysis will need to be weighed up by anyone considering future meta-analysis. But I hope these insights may provide a useful case study to show the added value that IPD analysis can bring. So this brings me to the end of my slides now, but happy to take any of your questions.
Thank you very much, Dr. Cro, for that illuminating talk on the value of individual patient data meta-analysis. I recall back in 2004, I was doing some of this type of work looking at whether or not statins and fibrates affected melanoma incidence, and going to the trial lists to get this data was quite difficult initially, and that was one of the things that drove me to seek the help of Cochrane Skin and Howell Williams and the Skin Group to help persuade trialists that the effort was methodologically rigorous and would come up with an answer that would be meaningful. And with that help, we were able to look at that. So I commend you in this work. It's not easy, and it takes time and effort to analyze more data.
Definitely.
Do we have any questions in the chat? I see Hal Williams congratulating you as well.
Thank you.
Laura's got a question, I think.
Laura?
Hi, Suzie. I really enjoyed your talk. I was just wondering about how one of the disadvantages of the aggregate data seemed to be that you didn't always have all the data, so you had less studies involved in it, if I've understood it correct. So is that to do with the reporting of the, because some of the studies didn't report the aggregate data?
Yes, yeah, that's correct. So I think it's most notable in the adverse events outcomes, and I know there's quite a lot of literature out there that's that talks about the poor reporting of adverse events in the publications of clinical trials, because obviously they are limited by journal space. Although in theory, you can put as much as you want in a supplementary appendix. So really, all the important bits should be there. But particularly for those, we found that there was the trialists hadn't reported the specific information in the publications, but in the data they supplied us with, we could find that data on adverse events that had been recorded.
Yeah. I guess that kind of like, I don't know if it's a question or just a thought, but like if all the studies have very well reported their aggregate data for all the outcomes, do you think that if in that situation, would you say, okay, it's less important to do IPD, or would you still think it's got benefits beyond that will make it worthwhile? Yeah, so
that's a good question, but I would say it's probably still worthwhile, because whilst they might have still reported every outcome, they might not have reported missing data sensitivity analysis for every outcome. And it's most typical, good trials will report missing data sensitivity analysis for their primary outcome, but you don't often, even in the supplementary appendix, see some sensitivity analysis for missing data for secondary outcomes, which will form part of the review outcomes. And also, so that will affect your risk of bias assessments. So there's other considerations as well, and the fact that IPD meta-analysis allows you to use consistent statistical methods across the trials. So here we were consistently adjusting the sex and atopy. So this all helped to sort of increase the precision in estimation and also reduce the heterogeneity, which I think was quite stark in the eczema analysis for the primary outcome. It really showed the Skjerven trial standing out. So I think even if they have reported things very well, which some of the trials did, then I think it's still very valuable.
Okay, that's really helpful. So it's not just about the reporting; it goes beyond that. Yeah. Yeah,
I mean it's a key issue. The reporting's the big issue, but there's other things as well.
Okay. Can I make a comment, Rob? I think Matthew Grange, as the statistics editor for the group, has made a good comment in the chat that it was a big effort to get the data sets on those 10 trials. And as Suzie says, even if the trials are beautifully reported, the data are not always analysed in the same way, so you can't pool them in a meaningful way, and you lose definition and confidence in your findings. So the only real way to do this is for all the trials to publish their full data sets, and then every single Cochrane review becomes an IPD review. If it's important and you want to be as confident as you can be in the findings, then do IPD. And if all the data sets were up there online from the trials, it would save probably a couple of years of work in terms of negotiating with all the partners, doing data sharing agreements and chasing them up for missing bits of data and clarifications. So that really is the solution in the trials field, is for all trial data sets to be publicly available. And that will give us much more confidence in what the science is telling us.
Definitely, I look forward to that day.
Can we ask for core outcome measures in all the trials while we're at it?
That would be good as well.
Okay, any more questions for Suzie? For Dr. Cro? Thank you, Dr. Cro, for joining us. At this time, I'm going to stop the recording.